Welcome back to The Explainer. Today we're diving into a literal cosmic detective story that is absolutely captivating the astrophysics world right now. Two of our most powerful eyes in the sky, the James Webb Space Telescope and the Chandra X-ray Observatory, have teamed up to crack a mystery that fundamentally changes how we look at the early universe. So let's just start with the ultimate question. How exactly do you build a supermassive black hole? Sounds simple enough, right? Well, honestly, it's been one of the biggest unsolved mysteries in the cosmos. We see these absolute monsters lurking at the centers of galaxies, but how they actually got so incredibly massive, so insanely fast right after the dawn of the universe, it's completely baffled astronomers for years.
All right, part one, a cosmic mystery.
To really grasp the scale of this mystery, we got to look at the two main theories scientists have been arguing over. First, you have the bottom-up theory. This is the idea that when massive stars die in supernovas, they leave behind smaller black holes that slowly just kind of bump into each other and merge over billions of years. It makes logical sense, sure, but it is way too slow to explain the giant black holes we see in the very early universe. Then you have the competing top-down theory. This suggests that vast ancient gas clouds, some with millions of times the mass of our sun, just collapse directly under their own gravity, instantly creating massive black hole seeds. Now, this perfectly explains the timeline, but until recently, it completely lacked any definitive smoking gun proof.
And that lack of proof, that's exactly why what we're talking about today is so absolutely crucial. We're not just, adding a tiny footnote to a textbook here. People in the field are literally saying this could be the biggest cosmological discovery since we found out about dark energy back in 1998. Yeah, it is that huge. Solving this mystery gives us the actual blueprint for how the universe as we know it was constructed.
Which brings us to part two.
The little red dot.
So the James Webb Space Telescope starts looking into deep space with those incredibly sensitive infrared cameras, right? And it starts spotting these super puzzling objects that astronomers simply nicknamed little red dots. And these things are ancient. We're talking 12 billion years ago, maybe even older. We are looking way, way back into the very infancy of the cosmos. Now, a recent study zoomed in on these and found their temperatures range from about 3,100 to 6,700 degrees Fahrenheit. Now, I know, to you and me that sounds absolutely scorching, but in astronomical terms, that is surprisingly cool. Actually, it's cooler than our own sun. And amazingly cool enough that researchers actually found water vapor inside them. So just to recap the sheer weirdness here, we're looking at objects just a few hundred light years across, cooler than most stars, packed with water vapor, and sitting at the very edge of the observable universe. It is a massive paradox. How on earth could something so incredibly small and cool hold the secret to the most violent, massive objects out there? Let's move to part three, the X-ray connection. To crack this case, we actually have to look at a totally different telescope and basically reopen a 10-year-old space cold case. Get this. A decade ago, NASA's Chandra X-ray Observatory picked up this random signal. They called it 3D HST Aegis 12014. Catchy, right? It had the energy of a quasar, which is a galaxy with a super active black hole. But it just kind of sat there in the data archives collecting digital dust. Then, recently, JWST finds our little red dots. And here is the huge aha moment. Scientists overlap the maps and realize, wait a minute, that 10-year-old X-ray signal and one of these newly found little red dots are in the exact same location. I just love this quote from Princeton astronomer Andy Golding. He pointed out that this X-ray dot had literally been sitting in their Chandra survey data for over 10 years, but they had absolutely no idea how remarkable it was until Webb came along to look at the same field. It was hiding in plain sight the entire time. We just needed both X-ray and infrared data combined to finally see the big picture. Okay, part four, inside black hole stars. So we have our clues. We have the timeline. Let's put the puzzle together. The answer to what's happening here? A black hole star. Which, yeah, totally sounds like an oxymoron. But these little red dots aren't normal stars at all. They are actually these massive, super dense clumps of gas that are glowing because they are being energized by a growing, supermassive black hole completely hidden inside. That red dot is just the cool outer shell of gas hiding a ravenous monster. So here's how the mechanics actually work. Usually, the dense gas around a growing black hole just absorbs all of the X-rays. Nothing gets out. But here, the black hole is feeding so aggressively, it's literally eating the gas cloud from the inside out. This clears out huge cavities, basically blowing physical windows into the cloud. Finally, those high-energy X-rays have an escape route.
They shoot through these windows, travel 12 billion light years, and hit our Chandra telescope. And because this whole massive cloud is spinning, those windows are constantly rotating in and out of our line of sight. That is exactly why Chandra saw the X-ray brightness flickering and changing. We are literally watching this incredibly violent process happen in real time.
And finally, part 5, solving the galaxy puzzle.
So, bringing it all back to our very first question, what does this all actually mean? It means we found a transitional object. It is the ultimate missing link. We are seeing a supermassive black hole going through its awkward teenage phase, stuck right between being a fully enclosed seed born from a collapsing cloud and the mature, naked supermassive black holes we see powering active galaxies today. And this is the smoking gun that strongly confirms the top-down theory. Supermassive black holes really can just form directly from the collapse of vast gas clouds. Raphael Heividing from the Max Planck Institute for Astronomy, he's the lead author of the study, he completely hit the nail on the head. He said that this single X-ray object may literally be what lets us connect all the dots. Pun, totally intended, I'm sure. It takes all these totally separate puzzle pieces and snaps them into one perfectly coherent story of cosmic evolution.
So, what are the big takeaways for us today? Why does all of this matter? Well, first, it proves the top-down model. Massive gas clouds collapsing to make black holes is a real, proven mechanism. Second, it shows these black holes can grow unbelievably fast in the early universe, basically gorging themselves in secret inside these gas cocoons. And third, this isn't just about some weird dots in deep space. This is about us. Figuring this out helps explain the early history of galaxies, which literally gives us the blueprint for how our very own Milky Way was built.
Which leaves us with kind of a crazy final thought. If these tiny, ancient, incredibly distant little red dots were the hidden engines that eventually built galaxies like our Milky Way, what else is just sitting there in our old archival data, just waiting for the right telescope to come along and finally reveal it? What else is hiding in the dark? Anyway, thank you so much for joining me on this explainer today. Keep looking up and definitely stay curious.